Hello everyone, it's Wilson here. Today I want to talk about finding a vector function for the circle with a given radius and also with a center at a point, right? And so you can see that the radius is 3 and then the center of the circle is 1, 2, 0. And also the circle is supposed to be lying in the xy plane. In this case, because it's lying in the xy plane, we have the circle that's actually a plane curve, right? So even though we are talking about a curve in the space, but the circle is just laying flat on the xy plane. Okay, so if we are graphing, this circle right here, right? So let's just graph the xy plane first. So I have the xy plane here. And then, so just one thing that I want to point out is that I'm just graphing the xy plane. And then you may say, what about the z-axis? The z-axis is actually, the positive z-axis is pointing toward you, right? It's toward the screen. So in here's, what do we have? We have the center to be 1, 2, 0, right? So 1 for the x and 2 for the y, right? As you can see here. So we have x, y, and z. So 1 for the x, so you get 1 unit right here, and then the 2 for the y, so we are going to get 1, 2. So now our center for the circle would be at this location right here. So the center, right, is going to be at 1, 2, 0. Okay, so now we actually need to graph the circle. If I'm graphing the circle freehand, I think that it will be an ugly circle, but I will try my best. So if we go 3 units in every direction from the center, then there is 1 point right here, and then we go 1, 2, and 3. Then that's the other point, and then if we go up 3 units, so 1, 2, and 3, then we get another point right here. Go to the left, 1, 2, and 3, then we are going to get that point. So let me try. I think it's just going to look really bad. So we have the circle. Okay, I try my best, but that's the circle that we want, right? If you actually just draw this, you just imagine that in the space. Then, if you're using your table or your desk as the xy plane, and then just put a pen or pencil, right? That's perpendicular to your table surface. Then what happens is that the circle is really just the circle that you are drawing on your desk on the table. But then the z-axis is actually the pen that you have that's pointing upward. Okay, so now our goal here is to find a vector function for the circle or a parametrization for the circle. How do we do that? First, we can actually come up with the Cartesian equation for the circle. In this case, it would just be, it's really simple. It would be x minus, now the center, right? So x minus 1, right? Minus the x value of the center, and then plus, now y minus the y value of the center. Okay, and then there was not a z value in there because we are not talking about a surface. We want a curve, so now we just have that. You may say, why do we get 9 here? Because it will be the radius square here, right? So this is r squared, so square the 3, then we get the 9. And then you also need to specify one more thing about the z. What about the z? The z is going to be 0. Why is the z 0? Because no matter which point that you pick on the circle, it's going to lie on the xy plane. And what is the z value for any point that's in the xy plane? Is 0 for the z. So that's why we have the z equals 0 right here. Okay, so now we have the Cartesian version. How do we come up with the parametric version here? It's actually really simple. All we need to do, okay, so all we need to do is to claim that the stuff in here would be 3 cosine of t, and then claim the stuff in here in this second group right here, the y minus 2, as 3 sine of t. Then you can see that if you square, okay, so let's just do some quick calculation right here. This is not part of the solution, but if you just do some quick calculation on the side, do you see what's going on here? You do you're actually getting 3 cosine of t squared plus 3 sine of t squared, right? And what is that actually equal to? So I think, what is that actually equal to? If you square the 3, you get 9, and then you get 3 cosine t, and then plus cosine square t, and then you get 9, and then sine square t. So factoring out the 9, then you're going to get cosine square t plus sine square t. What is cosine square t plus sine square t? We are actually getting 1. 1 times 9 is just 9. So that will satisfy this equation. And that will give you a circle, as you know, right? So now that really just saying that, okay, so we have x minus 1 is equal to 3 cosine t. And then the other one is going to be y minus 2. That's equal to 3 sine t. Okay, so what we want right now is to solve for x and solve for y, right? So if we solve for x, we are going to be getting x equals 1 plus 3 cosine, right? 3 cosine t. And then if you solve for y here, then you are going to get 2 plus 3 sine t. Okay, and then we also need to set a restriction for the t, but you know that from polar, then we know that we are going to just restrict the t from 0 to 2 pi, right? So that, yeah, in polar we actually use theta, but right now because we're just using a generic parameter, so we just use t. Okay, so this is the pair of parametric equations that you have. And of course, we also need to include that z is equal to 0. So right now, we are ready to write down the vector function for the circle. How do we write it? It would be this. So r of t, okay, would be, now what is the x component? The x component would just be whatever that you have right here. It would be 1 plus 3 cosine t. And then it would be what? 2 plus sine t for the y, right? So 2 plus 3 sine t. Yeah, 2 plus 3 sine t, not 2 plus sine t. 2 plus 3 sine t, okay? And then last one, it would be what? The z component for the vector, which is 0. It's always 0, right? No matter what t that you plug in. Is really because the circle always lies in the xy plane, right? And then now also include the domain for the t, which goes from 0 to 2 pi. And that's all we need, right? Because you chase the whole circle just once as you increase t from 0 to 2 pi. Okay, so that's it for this problem. By the way, I just want to mention that this answer is not unique, right? You can actually change some of the stuff in there, then you are still going to get the same circle. In the future, we are going to talk about coming up with different possible answers for the curve. But right now, it's just in this video, I just want to demonstrate how to come up with the parameterization or the vector function for a curve in the space or in the plane. Okay, so that's it. To help me make math learning available to everyone, please share my videos to others and subscribe to my channel. It will give me support to make more videos. Let's work together to help students and children learn math more easily. Thank you for watching this video.